What's up guys, welcome to another video. In this video I want to show you some examples regarding unit vectors and adding vectors by components. The first example here, I have two vectors are given by a equals to 4i minus 3j plus 1k and b is negative 1i plus 1j plus 4k. In unit vector notation, find a plus b and then find a minus b and then find a minus b plus c equals to 0. Find out the vector c. So for the first one, that's I, here we have j, and here we have k. So when we add these two, 4 minus 1 is going to be positive 3 meters. J is going to be negative 3 and plus 1 is going to be negative 2j. And k is going to be 1 and 4, which is going to be 5k. Here we have a minus b, which is going to be 4 minus negative 1, that's going to be 5i. Negative 3 minus 1 is going to be negative 4j. And 1 minus 4 is going to be negative 3k. Now it says when a minus b plus c equals to 0, find out the value of c. You can say c will be equal to b minus a. So what is b minus a? It's going to be negative 1 minus 4, which is going to be negative 5i, 1 minus negative 3, which is going to be positive 4j, and 4 minus 1 is going to be 3k. So that's going to be the vector c. In this example, a car is driven east for a distance of 50 kilometers and then north for 30 kilometers and then in the direction of 30 degrees east of north for 25 kilometers. Sketch the diagram and find out the magnitude and the angle of the car's total displacement from its starting point. So we will have 50 kilometers east, 30 kilometers north, and after that we have 25 kilometers east of north. So it's going to be something like that. That's 30 degrees. So we can say A is the first one. That's if we say this one is A, this one is B, this one is C. We can say A is 50 kilometers I, B is 30 kilometers J, and C is 25 kilometers sine 30 I plus 25 cosine 30 J. So now we can add them all. So that will be 25 times sine 30. It's going to be 12.5 kilometers I, and we have 25 times cosine 30, that's going to be 21.65 J. So in I we have 50 plus 12.5 I, and J is going to be 30 plus 21.65 J. So it's going to be 62.5 I plus 51.65 J. And the total distance or total displacement is going to be 62.5 squared plus 51.65 squared. And now we can calculate it. It's going to be roughly around 81 kilometers. So the resultant is going to be something like this. We need to find out the theta in here as well. So we can say tan theta equals to 51.65 divided by 62.5. So that will be 0.8264. Theta is going to be tan inverse of 0.8264. That will be almost 40 degrees. So theta, which is what you see in here, it's going to be 40 degrees. In this example, we have two vectors A and B have equal magnitudes of 10 meters, and the angle are theta 1 equals to 30 and theta 2 equals to 105 degrees. Find the x component and y component of the vector sum r, and also find out the magnitude and angle. So we can say A consists of AXI plus AYJ. B equals to BXI plus BYJ. AX equals to magnitude of A times cosine theta 1. AY equals to magnitude of A times sine theta 1. So it's going to be 10 times cosine 30 and 10 times sine 30, which is going to be 8.66 meters. This one is going to be 5 meters. Now BX and BY. It's going to be magnitude of B times cosine. When you have this one, that's going to be theta 1, and this one is theta 2, so it's going to be cosine theta 1 plus theta 2. And BY will be sine theta 1 plus theta 2. So that will be 10 times cosine 135 degrees and 10 times sine 135 degrees. That will be 10 times cos 135, negative 7.07 meters, and here 10 times sine 135 will be same thing in positive sign. So we can say Rx equals to Ax plus Bx. That will be 8.66 minus 7.07. Ry is going to be Ay plus By. That's going to be 5 plus 7.07. So here the difference is going to be 8.66 minus 7.07, 1.59 meters. And here we have 5 plus 7. It's going to be 12.07 meters. If you want to find out the R, we need to have Rx squared plus Ry squared. 1.59 squared plus 12.07 squared. That make it around 12.2 meters. How to find out the angle? We can say theta equals to tan inverse Ry over Rx, which is going to be tan inverse 12.1 divided by 1.59. It's going to be 82.5 degrees. In this example, what is the sum of the following four vectors in a unit vector notation? What is the magnitude and what is the angle? The four vectors here we have is 2i plus 3j, 4 meters at 65 degrees, c negative 4i negative 6j, and d is 5 meters at negative 235 degrees. So we can have, for first of all, let's find out B and D. B, we can say is gonna be equal to bxi plus byj. Bx equals to b times cosine 65. By is going to be 4 times sine 65. Dx equals to 5 cosine negative 235, and by equals to 5 sine negative 235. So we have 4 times cosine 65, 1.69. 4 times sine 65, 3.62. 5 times cosine negative 235, negative 2.87. 5 times sine, that's going to be 4.096. Or we can round it to 4.1. So now the sum is going to be, let's say Rx equals to Ax plus Bx plus Cx plus Dx. It's going to be 2 plus 1.69 minus 4 minus 2.87. That's going to be 2 plus 1.69 minus 4 minus 2.87. It's going to be negative 3.18. Now Ry equals to 3 plus 3.62 minus 6 minus 4.1. It's going to be negative 3.48 J. This one is actually plus, so it's going to be 4.72. So the magnitude is going to be R equals to Rx squared plus Ry squared. So negative 3.18 squared plus 4.72 squared. When you find out the square root, is going to be 5.69 meters. And then the angle is going to be theta equals to tan inverse Ry, which is 4.72, divided by negative 3.18. So it's going to be 4.72 divided by negative 3.18. Tan inverse of negative, this one is going to be negative 5, let's say 56 degrees, comparing to x-axis. So it is going to be somewhere here, and this one is 56 degrees. So from here to here, that's what we are looking for from positive x. We have 180 minus 56. 180 minus 56 is going to be 124 degrees. That's going to be the angle from here to the positive x-axis.